Have you ever felt like you're just fighting a completely losing battle with your backyard pool? You know the drill. You test the water in the morning, meticulously measure and add your chemicals, test it again at sunset, and somehow the numbers have wandered off to completely different extremes. It's incredibly frustrating, right? But here's the real kicker. In the middle of all this constant struggling, why are you continuing to overpay for those giant buckets of branded alkalinity increasers at the pool store? Well, in this explainer, we're going to unlock a water chemistry secret from our source materials that will not only stabilize your pool, but keep a whole lot of money right where it belongs, in your wallet. So let's talk about the reality behind those expensive, heavy buckets sitting in the pool supply aisle, because it's honestly kind of shocking. If you grab one, turn it around, and actually read the active ingredients, you'll almost always find just one single chemical listed: sodium bicarbonate. And do you know what sodium bicarbonate is? It's baking soda. Seriously, the exact same pantry staple you use to bake cookies or freshen up your fridge. The chemistry is absolutely identical, literally atom for atom. But that shiny pool store label? Yeah, that comes with a massive markup.
Okay, here's our quick roadmap for today's explainer. We're covering 1. The ultimate pool care secret. 2. pH's bodyguard, total alkalinity. 3. Baking soda versus soda ash. 4. The golden dosing rule. And 5. When can you safely swip?
Let's dive right into Section 1, the ultimate pool care secret. To really understand why basic baking soda is such a superpower for your pool, we first have to separate a concept called total alkalinity from pH. Now, while pH measures how acidic or basic your water is, total alkalinity, or TA for short, measures the concentration of dissolved alkaline substances in the water. We're talking mostly bicarbonates here. Ideally, you want to keep this level sitting right between 100 and 150 parts per million. Think of total alkalinity as the absolute foundation of your pool's stability. It doesn't dictate if the water is acidic. Rather, it dictates how stubbornly your water resists becoming more acidic. Which brings us perfectly to our next section, pH's bodyguard, total alkalinity. So what happens if your total alkalinity is low? Let's say it drops down to around 40 parts per million. Well, your water now has almost zero buffering capacity. And this introduces us to the absolute villain of pool care, pH bounce. Without alkalinity, your pH just crashes wildly. You add a cup of acid, the pH plummets. A heavy rainstorm rolls in, and it shifts all over again. Attempting to adjust your pH while your alkalinity is out of whack is, as one of our sources so perfectly puts it, like trying to steer a car with loose lug nuts. I mean, you'll get somewhere, but definitely not where you intended. And this acidic bouncing water causes real expensive damage. We're talking eating away at metal ladders, etching into your pool plaster, and causing some serious eye irritation for anyone swimming. The solution here is letting total alkalinity act as your pH's heavy-duty bodyguard. It is the shock absorber. When a heavy bather load hits the pool, say a huge pool party or an acidic rainstorm pours down, the total alkalinity steps up and takes the brunt of that hit, long before your delicate pH is ever affected. By using baking soda to raise your alkalinity back into that ideal range, you give the water its buffering capacity back, and just like magic, the pH stops wandering. Moving on to Section 3. Baking soda versus soda ash. Let's look at the showdown. If you look at these two white powders side by side, it's pretty confusing. On the one hand, we've got sodium carbonate, which is commonly known as soda ash, and on the other, sodium bicarbonate, our trusty baking soda. To the naked eye, they are absolutely indistinguishable, but from a chemistry standpoint, mixing these two up can cause a massive DIY disaster right in your backyard. It is absolutely crucial to know exactly when to deploy which powder. So here is the rule to live by. If your total alkalinity is low, use baking soda. Baking soda primarily raises that alkalinity buffer and only gives your pH a very slight gentle bump. However, if your total alkalinity is already sitting perfectly in range, but only your pH is too low, then you need to reach for its aggressive cousin, soda ash. Soda ash aggressively consumes hydrogen ions and forces that pH upward, and it does it fast. But man, you have to handle soda ash with care. If you add soda ash to water that has dissolved calcium in it, and let's be real, most pools do, it triggers a rapid chemical reaction. It forms calcium carbonate, which is a solid precipitate. Literally, in an instant, your beautiful crystal clear pool will turn into this dreaded, milky, cloudy haze. It looks exactly like a disaster. Thankfully, it's usually a temporary one, but you're going to have to run your filter continuously for hours just to clear it out. This exact scenario proves exactly why baking soda is the much safer, way more forgiving tool for your routine water buffering. All right, Section 4, the golden dosing rule. Let's get into the math. According to the source materials, here is the golden ratio that simplifies everything, so memorize this number. 1.5 pounds. Adding exactly 1.5 pounds of baking soda per 10,000 gallons of pool water will raise your total alkalinity by exactly 10 parts per million. That right there is the baseline math that totally makes you the master of your pool's chemistry. And to lower your cognitive load even further, we've got a quick cheat sheet for you. Let's say you have a standard 15,000-gallon pool, and your latest water test shows your alkalinity is 20 parts per million too low. Just follow the numbers. 15,000 gallons, move over to the 20 ppm column, boom, you need exactly 4.5 pounds of baking soda. No more pouring and just guessing by eye, the math does all the heavy lifting for you here. But listen, how you physically add it matters just as much as the math. Step 1. Always test your water first. Never assume. Step 2, calculate your dose based on those numbers we just saw, and if it's a really large amount, say anything over 5 pounds, you need to split that into 2 separate doses. Step 3 is vital. Broadcast the powder in wide arcs as you walk around the deep end of the pool. Never, ever dump the powder directly into the skimmer, because that can severely damage your expensive pool equipment. And finally, step 4, leave the pump running and let it circulate for a good 4 to 6 hours before you even think about retesting. And that brings us to our final section. When can you safely swim? The absolute beauty of baking soda and basic pH adjusters is that they are incredibly fast-acting. As long as your pump is running, you generally only have to wait 20 to 30 minutes before jumping back in. Contrast that against the heavier chemicals, calcium and liquid chlorine. Those require a 2 to 4 hour wait. Heavy pool shocks demand 8 to 24 hours of waiting. And flocculants, the stuff that clumps debris together, they ground your pool for a massive 24 to 48 hours. But, and this is a really big but, the clock on the wall isn't the final judge here. These times are just estimates. Your wait time could be extended by a bunch of different variables. If you have a massive pool, a weaker pump speed, or if you had to add a really strong dose of baking soda, the chemical just needs more time to physically move through the water. Even your starting water conditions, like heavy debris or an algae bloom, can totally slow the process down. So the absolutely crucial point you must take away from this explainer is the ultimate golden rule of pool safety. Read, circulate, test. No matter what the clock says, you should never let anyone swim until the water has been physically retested and the chemistry is confirmed safe and back within that ideal range. Testing is your one and only true green light. Well, we've covered a lot of ground today, but it really all comes back to one simple truth. By understanding the interconnected relationship between total alkalinity and pH, and by utilizing that golden dosing rule, you hold the power to master your pool's stability. So, here is the question you really have to ask yourself right now. Are you ready to stop chasing your pH, stop overpaying for those fancy pool store buckets, and finally take control of your water chemistry using the ultimate cost-saving secret sitting right there in your kitchen pantry? The choice is totally yours. Thanks for joining me on this explainer, and hey, happy swimming!